Okay, today we will have a group project, right? And then you have to identify problem and take a case study using advanced analytical model, where you have to get the data set and provide detailed solution using deep learning in artificial neural network. Okay, you have to provide step by step on how data been analyzed with deep learning techniques. Okay, and as a guide, you can use this cross-industry standard process for data mining, as we have learned in our class. Okay, so now we will have a presentation by group leader and group members. Okay, thank you. Please.
Assalamualaikum and hi everyone, I'm Amir and today I'm going to present our project. Our project title, as you can see here, tomato leaf disease detection using CNN and fast API. Problem and project objectives. The project objectives: build CNN model for disease classification and pre-process and augment image dataset, and train and evaluate performance of unseen data. The fourth one is deploy with fast API for real-time predictions, that we need to make a website that can make the process easy and quickly. Any farmers can access to this website and can put the image, and the model can detect this image for him. And the last one, create an accessible diagnostic tool for farmers. This, as I mentioned in the fourth one, that it will make this tool for the farmers with limited resources. They can access for it and detect any image they have on his farmer. Problem statement: as you know, the tomato disease, it's a very important part of agriculture that will reduce the crop yield and quality. And the second problem is the manual exception is slow and costly. Slow, it will take many time, and costly, it's so expensive. And the third one is the farmers in rural areas lack expert support. They don't have any expert from any people or any expert supporting. And the fourth one is the late detection create economy loss. That's when you are late detection of the tomato disease, that will damage the prediction of of the tomato in your farmer. And the third slide talking about the dataset description and selection rationale. And the total image we use it in our model, in our project, is 80K, and we use it in 4 classes. The first class is bacterial spot, and the second one aerial blight, and the third one light blight, and the last one is healthy. Move to the next slide. The next slide talking about the image pre-processing steps. The first steps, it's resizing. As I mentioned in the last slide, we resize all images 80K, converted from 224 times 224 pixels. And the second step is normalization. Pixel values scale to 0 and 1. All image values, it will scale to 0 and 1. And the third steps is data augmentation, random flip and rotation, zoom and contrast adjustment. And the fourth one is data splitting. As I mentioned, some of these steps, I mentioned it in the last slide. We split the data for 3 parts. The first one, training with 80%, and validation with 10%, and testing with 10%. The next slide talking about the model architecture. The section 1, architecture overview. In this project, we designed a CNN to process a leaf image as a classified plant disease. The model takes a RGB image of size 224 times 224 times 3 as input for this model, and the structure constant of 3 2D layers with ReLU activation, each held by the max pooling 2D layer to reduce spatial demonstration. And we also add a dropout layer with a rate of 0.4 to help prevent overfitting. And the second section, a layer breakdown. Most of them, this is what we use: the conv2d 32 filters and 3 times 3 kernel ReLU, and the max pooling 2D 2 times 2. And we use another we use a convd, but with a different number of filters. It's around 64 filters as 3 times 3, not the last one 2 times 2. And the max pooling 2D, 2 times 2. The third section talking about the output classes. Our output classes, as I mentioned in the second slide, it's like early blight and late blight and the bacterial spot and healthy. The optimizer and loss function. The optimizer we use it is Adam to adapt learning rate optimization, and the loss function is space categorical and suitable for multi-class classification with integer labels, especially in the hot vectors. So the second section is a validation strategy. We use epoch up to 40 and the batch size is 32. The third section talking about the training configuration. The validation set, as I mentioned, is 10% of the data. The ensures extract from the training and test sets. That to know the strike from the training and test sets. The regularization techniques. The first one dropout rate 0.4 to prevent the overfitting, and the data augmentation to increase the training and the early stopping to halt training when the validation have no improvement, so we can stop early stopping because there's no improvement and performance stringence. And the hypo parameters tuning, the manual tuning of learning rate and drop out rate and the number of filter we use it in our project, and the goal balanced training accuracy and generalization.
Assalamu alaikum, Doctor. I'm Zaid Khalid. I'm going to continue with model evaluation and performance metrics. So for the test accuracy, we have achieved around 90% accuracy on the data set, which indicates the model has generalized well and hasn't overfit to the training data. And looking to the confusion matrix inside, we see that most classes are detected correctly, especially the tomato particle spot and tomato healthy. So there is a minor confusion between early and late blight, which is expected due to the visually similarity in the leaf symptoms. But the model has achieved 100% accuracy for the healthy class with no false negatives. In terms of precision, recall, and the F1 score, all classes has score high, mostly between 0.92 and 0.99, which shows reliable classification across all the disease types. We use the F1 score matrix because it's more robust in cases of class imbalance. We also rely on macro averaging to treat each class equally, regardless of how many samples it has. And finally, for the ROC score, we have scores about 0.98, and this confirms that the model has a good, accurate classification in different thresholds. Next, for the classification matrix inside, here we take a closer look at the classification metrics per class. The overall test accuracy is reported as 92% across 704 samples, which is strong result for multi-class problem. The tomato healthy class performed the best, achieving 100% recall, meaning all healthy leaves can be correctly identified without error. The tomato late blight has an excellent precision of 98%, but slightly lower recall of 0.81, meaning some actual late blight cases were missed. For the tomato early blight showed the weakest performance with precision at 76%, indicate more frequent misclassification into neighbor classes. So these metrics highlight that while the model has accurate overall, some disease type, especially those similar visual traits, can be hard to distinguish. And thank you.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Al-Walid. So let's continue with our presentation. So we have this part model development with fast API. So why fast API? Lightweight and high performance Python web framework and fast interface with the initial support, auto-generate interface API, document VI, open API, and Sugar. Development process, trained model saved as H5 files, and fast API upload model and expose protected and endpoint, and image received to processed and then prediction rated as GSON. So tool used is Ubiquitron as the ACGI server and response format example, GSON and copy code, like here we have the example here, and real world utility can be integrated into mobile web apps, and frames can upload live image and get real time changes. So let's move to next part. We have here model insert symbol prediction interface example. We have here in the figures here new tomato live image and this is during training. Model correctly predicts late right, and confidence score is around 98%. Multiple symbol predictions is model testing on all four classes: early blight and late blight and political spot and healthy. So accuracy of prediction start from 90 to 100%, lowest confidence around 84.9%, still correct. And generalization strength is correctly hints and variation image condition, lighting, angel, and background. We have here the keys, findings, and conclusions. The high classification performance. Testing accuracy is around 90% with F1 score 0.29 to 0.99 across these classes. Healthy leaves 100 true negative rate, no missed diseases, and effective operating mutations that with the mutation plus dropped 0.4 plus L3 stopping keeping training validation GAP manual and learning courses how parallel improvement and convergence. So third one is vertical development success is fast API developer interface in this one S1 CPU ready for real-time field use, and Discord container issues portable called ready solution, and rejectable implement enables early disease detection and reduction crop loss and terminal cost, and also improvements for frames with an accessible, scalable, and digable tool.
Assalamu alaikum warahmatullahi wabarakatuh. I am Muhammad Nasser. Today I will complete with the coding part and the demo part. And actually, in our project, we use a convolutional neural network to classify the leaves. This is from the images. Actually, our model consists of 6 convolutional layers followed by max layers to extract the features like edge and shape and patterns. After feature extraction, the output is flattened and passed through 2 dense layers, one with ReLU activations and one with softmax to classify into the correct disease class. Actually, we applied image augmentation to improve model generalizations, and it trained the model for 20 epochs. Actually, we have trained with 20 epochs because one of the disadvantages of neural network, if we have a lot of database, it will take a lot of time to take. So we cannot like so. And actually, we have used Atom Optimizer and categorical cross entropy loss. As we see, we can drag and drop the image, the tomato plant leaf, to showing the confidence at accuracy. So if you take an example of tomato late blight, we can see that the label is tomato late blight with a confidence 88.12. And if we take an example of tomato early blight, we can see that the label estimate early applied with 97.75%. Let's check the healthy. We see that it gives us 90% confidence. So that's a good one.
So last things we have a question. What kind of activation functions did you use and why? Well, actually, we used ReLU, the convolutional and density settling layers, and ReLU and is popular because it's introduced non-entity. And in the output layers, we used softmax because our task is multi-classes classification. So in conclusion, the project successfully demonstrate the convolutional neural network CNNs and are powerful tools for classifying tomato leaf. This is with the high accessory through rigorous processing, restructure training, and validations. The model achieved approximately 90% accuracy and show strong generalization without overfitting. And to end solution from data collection to development processes, the deep learning can effectively address real world ethical challenging and contribute to early disease diagnosis, better crop management, and improved food security. Thank you.